Hi, this is a companion video to my previous tutorial on materials, or how I learned to stop worrying and love the main.materials.json file. In that video, we created a cheese cube in Blender, and then we assigned the textures to the material in BeamNG.drive. In this video, I'll show you the tools and workflow that I used to make the textures for that block of cheese. Okay, so here's the texture set I used. I included several maps, but depending on what you're making, you may not need all of them. At a minimum, I would say that you need to have a base color and a normal map. A quick note, we're focusing primarily on static objects placed within a map, but if you're creating terrain materials, you must include an ambient occlusion texture, otherwise the map will not render. You can check out my terrain materials video tutorial for more information. Okay, so for the sake of demonstration, let's go ahead and create a new working folder for cheese version 2. So first things first, sources. There are a lot of great texture resources online. Some are free, some that are paid. You'll find a variety of sizes, file types, aspect ratios, and image modes, so make sure to find the one that works right for your project. Sometimes you might even find complete texture sets. The important thing is to follow fair use and licensing rules. Don't use somebody else's work without proper permission or a valid license. There are plenty of free texture sites available, like Texture Labs or Pexels, and some industry standard platforms like Polygon offer some free materials as well. Alternatively, if you can't find exactly what you need, you can create the textures yourself using image editing software like Adobe Photoshop or GIMP. You can also generate textures using AI tools or by building procedural materials with node-based math inside tools like Blender. Another great option is to use the developer textures that ship with BeamNG. The developers openly allow these textures to be reused. You don't even need to copy the files into your map folder. You can just reference them in the main.materials file. I cover that in my Add Developer Models to Your Custom Map tutorial. Bonus tip, a few modders and I actually put together pre-built Blender material libraries that use the developer materials to make assigning and texturing models way easier and faster. I'll link the zip file in the description if you want to download it. It's about 3.5 gigabytes. And if there's enough interest, I may make a standalone video covering that setup. Now let's go over some tools that I like to use when creating textures. One free website that I use is Texture Generator Online. This is helpful for generating things like Perlin noise, fractal noise, and turbulence, and there's procedural patterns that can help break up flat surfaces and make your materials look more organic and less artificial. Let's go ahead and make a brick texture using this tool. Go ahead and click on brick in the texture type. You can change the pattern if you like. You can change the size here, and then you can pick the colors. So for brick, let's go with like a red color. For gradient, we could say maybe orange, and then grout, we'll do like a tan color. You can change the size for all those, rotation if you like. And then at the bottom, you can select the dimensions. We've got 512 by 512 for small, which is the default. 1024 by 1024 for normal, big, and huge. They're all powers of 2. And then we rename the file. We could say brick_b.color. And then you can select the file type, which would be PNG or JPEG. We're going to go with PNG and click download. Another great tool is Simple Ripper, which is made by a guy named Pizza Doggy. This tool allows you to add any image and cleanly extract quad-shaped textures from the base image. I'll show you how this works. So if you click Run Tool, now we get this nice tool that allows you to drag and drop images into the editor, or you can click the top left corner to select an image from your folder. I'm going to drag and drop this cheese image I have saved into the editor. Then we can adjust the handles on the quad to crop the parts that we want for our texture. This current texture is now rectangular, so we can adjust that if we want to make it more square. As long as the final dimensions are powers of 2, we should be okay. If they aren't, you might need to resize it a little bit in GIMP or Photoshop. Some quick tips about this tool. If you want to add more quads, you can do that by pressing the purple plus button. This allows you to adjust multiple texture quads for a single image. You can also tweak the output sharpness and contrast, and there's some great navigation shortcuts to check out as well. So these are some great web-based tools, but if you're looking to create your texture set from scratch, the best comprehensive tool in my opinion is a desktop application called Materialize from Bounding Box Software. This is what I use for almost all of my custom textures. Materialize is a standalone tool for creating game materials from images. You can create an entire material set from a single base image, or import the textures you do have and generate the textures you still need. Okay, let's make a texture set. So we'll start with our base color cheese texture. Now let's open Materialize. On the bottom half of the screen, you'll see a gray 3D preview object. You can hold right-click to orbit around it, and hold the middle mouse button to pan. At the top left, you'll see map slots. Each slot includes a preview window and a few buttons below it. P for paste, C for copy, O for open, and S for save. Below that, there's a quick save button and then a preview button. This lets you isolate that specific map in the render view. And lastly, at the bottom of each section, you'll see a create and a clear button. The create will be grayed out until there's enough information to generate that map. Clear removes the current map, and if a map is already generated, the create button will actually change to an edit button that opens a panel where you can tweak the settings. If you're starting from scratch, you'll want to begin with the diffuse map. Let's go ahead and click O on the diffuse map and open up our cheese base color file, which is cheese_b.color.png. Now that the diffuse map is loaded, we can use it to generate the rest of the texture set. Start by creating the height map. Once that looks good, let's generate the normal map from the height. And then after that, we can create metallic, smoothness, which is also called roughness, and finally the ambient occlusion map. As you adjust the settings for each map, you'll see the changes reflected immediately on the 3D preview object. Great, so when you're ready to export, let's choose PNG as your file format, and then click Save Project. Materialize will then export all generated maps to the folder that you select. A quick bonus tip, we talk about this in the materials tutorial, but in BeamNG.drive you can actually use a combined property map to pack multiple maps into a single texture image. So ambient occlusion would go into a red channel, roughness in the green channel, and metallic in the blue channel. You can specifically generate that combined map directly in Materialize by assigning each property to its respective color channel and then clicking Save Property Map to export that packed file. Sweet! Now we have a solid texture set. You may have noticed that this tool did not create the detail, opacity, or emissive maps. These will have to be configured manually as they're largely dependent on the goals or needs for the object. So we're nearly done. We just need to do two final things. First, we need to ensure the files are the correct image mode and encoding. And then secondly, we need to rename them to make sure they work with the texture cooker. So let's talk about image mode and encoding first. In order for the game engine to use the image files that we just generated, they all need to follow these guidelines. The base color should be RGBA 8-bit nonlinear. The base color detail should be RGBA 8-bit nonlinear. The metallic should be grayscale 8-bit linear. Roughness should be grayscale 8-bit linear. Normal should be RGB 8-bit nonlinear. Ambient occlusion should be grayscale 8-bit linear. Opacity should be grayscale 8-bit linear. Color palette map should be RGB 8-bit nonlinear. Emissive should be RGB 8-bit nonlinear. And clear coat should be grayscale 8-bit nonlinear. These are not hard and fast rules. If you have a 16-bit nonlinear metallic map, for example, it will still work. But a 32-bit linear normal map, for example, will not work. The textures we generated from Materialize should work just fine, but if for any reason you need to change the mode or image encoding, this can be done in Photoshop or GIMP. I like to use GIMP, so I'll just show you that real quick. You can open up the file, click on Image, click on Mode, and you can change it to grayscale if need be. Under encoding, you can change it from 8-bit to 16-bit to 32-bit. And you can also change it from linear to nonlinear at the bottom. Okay, now that we've talked about image formats, let's talk about the texture cooker. Texture cooker is a feature added to BeamNG.drive in version 0.2 that automatically converts properly named PNG texture files into optimized DDS formats when the game loads them. This helps improve performance because DDS is more efficient than PNG files for real-time rendering on the GPU. The way this works with the texture cooker is by using suffixes in the file name. There's currently three types of suffixes: color, normal, and data. So if the suffix ends in .color.png, it converts it to a BC7 sRGB DDS file that's used for diffuse textures primarily. If the suffix ends in .normal.png, it will be converted to a BC5 DDS for normal maps. If the suffix ends in .data.png, then it will convert it to a BC4 or a BC7 grayscale DDS for maps like ambient occlusion, roughness, or metallic. You can technically call your file name whatever you want before the texture cooker suffix, but best practices would be to mirror what the trained material already uses for bulk changes. Here's the naming schema that I use. Material name underscore b.color for the base color map, material name underscore detail underscore b for the base color detail map, material name underscore nm.normal for the normal map, material name underscore detail underscore nm.normal for the normal detail map, material name underscore m.data for metallic, material name underscore r.data for roughness, material name underscore ao.data for ambient occlusion, material name underscore o.data for opacity, material name underscore c.color for the color palette map, material name underscore e.data for the emissive map, and lastly, material name underscore arm.data if you have a combined ambient occlusion, roughness, and metallic map. Okay, I think that's about it. Once you have your image format, encoding, and suffixes taken care of, let's go ahead and move the files to your map. Then we can load up the game and see if the texture cooker works. So when the texture is first loaded, it will place the cooked DDS files in the current user directory temp folder. It's going to keep the same relative path as the originals. Let's go ahead and open up that temp folder, and we can see what happens when we load our textures. As you can see, the DDS files are starting to populate when I hover over the PNG file. I purposefully added that 32-bit linear normal map just so you can see what happens when the texture cooker tries to import it. It fails, but as you can see, the 8-bit linear one that we have here converted correctly. Lastly, if you're planning to publish your mod, you should move over all of the cooked DDSs from the temp folder to your map directory, and assuming the PNGs are backed up elsewhere, they can also be removed. The game will still look for and reference the PNGs in the main.materials.json file, but it will efficiently automatically use the DDS versions if they exist. One housekeeping note: if the system already has cooked DDS files and you want to rename or edit the PNGs, clearing the temp folder is a good idea so that it generates new ones from your changes. And one final bonus tip: if you ever wanted to convert the images to DDS yourself, maybe you want to skip the texture cooker step, you can use the NVIDIA Texture Tool Exporter to load the PNGs, set the DDS format, BC5 for example for normal maps, and save as a .dds format. So this workflow in total lets you work with familiar PNGs and ship and use efficient DDS textures without manually converting them. As always, if you have any questions, drop them in the comments. Thanks for hanging out, and I hope this helps.